I'm one of a team of three within the specialty of structural engineering. So I'll be representing my colleagues here, Dr. Paul Nowak and Dr. Sarah Ganserly. So what I'd like to do is, one, thank you for being here. And I'd just like to talk about really two things, one of which you already know, I think. So one of those is the what. What is structural engineering? And I think a fair number of you have some intuitive idea because you've been in a building, you've seen a building, you've dealt with structures, and so you're at least somewhat familiar with what structural engineering is. It's somewhat intuitive there. But then what I want to focus in on more so is the why. One, why am I so excited about structural engineering as a specialty and structural engineering within the context of Gonzaga University, which I think is really quite a special place. So I'd like to just give you an overview of some examples of projects, and in fact, examples of projects that I've been working on during my career, in part to show you just how much sort of the wide applicability of what you can do with civil engineering and the specialty of structural engineering. So I've had a chance to work on everything from mega tall, so that's you're looking at the skyline of Dubai right here with the Burj Khalifa. So where that's looking at, that's about 2,700 feet tall. All the way down to micro small, so micro cantilevers that are maybe 25 microns in length, and everything in between. So whether it's a water treatment center, a dam, a bridge, a building, housing, or even satellites that are out in space, things like that, all require some level of structural engineering to make sure that the structure can deliver what it needs to. During and everything in between, like I was saying there. So some examples of this, here's a 32-story building that I worked on, again in Dubai. It's a headquarter, and what's really neat there is there's that cantilever all the way over on the top story, and in the middle there you see this little glass ball, and that's where the chairman and the committee of the Mashroq Bank actually hold their quarterly meetings. So that was kind of interesting to design. And then you see over in China, we had the opportunity to work on an optimized structure. So this is a very high seismic zone and a very tall building. And so what we did was we came up with structural bracing, and we iterated over a whole bunch of different designs until we finally came up with the optimal solution that allowed us to both deliver a very tall building, but also one that was very sustainable in addition to being able to withstand very high seismic forces. Closer here to home, I've had the opportunity, two of my specialties are with composite materials. So working with laminated glass. So I don't know if you're familiar with this company at all, but they dabble in technology. And so I've had an opportunity to work on some of their headquarters. So designing the Apple Store in glass. There's a series of very large glass staircases. And then if we go over to the West Coast, I don't know if anyone on the call is from California and specifically LA, but you've got the Sky Slide. So up there, about 1,000 feet up in the air, you can slide off the side of that building. And if you trust my engineering, you'll have hopefully an exciting but a good experience sliding down those couple of stories here. So in addition to that, more recently, like Dr. Mazinski, working with consulting, where had an opportunity to work on facades for the Milwaukee Bucks. I'm originally from the Midwest, and so that's a new stadium that the city of Milwaukee and actually the state writ large is helping to pay off right now. And closer to home here in Spokane, we've got a lot of cross-laminated timber. It's just like glass in the sense that it's a composite material, highly sustainable. And so we've been working both with Kateria, which is a very large company, and also Vaughan, which is another company that's very close by here, to come up with a series of solutions that gives you sustainable options. And the reason that this is so exciting to me is because very early on in my career, I really enjoyed working with wood, building with wood, building even forts in the back of my yard. And so I've had an opportunity to work at large firms in Chicago where we dealt with high-rise buildings made out of wood. And then, like I said, it's not just for me about building buildings and coming up with new solutions and things like that, but really what's fulfilling, right? What do you get excited about? Because hopefully you're choosing engineering because that's something that's exciting to you. And so for me, what it was an opportunity to, would you believe that that's an actual fort that I built growing up? It's not, but so growing up, I really enjoyed building tree forts, and so now actually I also have the opportunity. That's probably more what they look like, and now I have the opportunity to build those with my daughter and now my son as well. And the thing that really inspires me beyond all that, beyond being able to design these buildings out of sustainable materials, is this idea of engineering, civil engineering writ large, and structural engineering in specific, as an opportunity to have a positive impact on our society and on our planet. So the whole point of being able to do more with less as an engineer. So limited resources in the world, but we're a world that needs to grow, right? There's going to be more and more people. So how do we effectively house those people? We have limited wealth, but we want to continue to create value. And sometimes we're a world of irresponsible excess. But we also want to be able to have dreams and inspiration. And so I think as engineers, specifically civil engineers, we're poised to uniquely be able to execute on these things. And so that's very exciting for me. Just a real quick thing, obviously you're probably all familiar with, there's more people on the planet. Every day we go along, there's more and more people. And so go back as far as you want, all the way to modern times, we've had a huge increase of people, which is an exciting reality to live in. But the question is, what do we do with all those people? So as you look at the United States, for example, increasingly, as our population goes up, more and more and more of those people are living in cities, in urban areas. And so as you look at, for example, the population in 2019, we had about 7.7 billion people. About half of them lived in cities. You fast forward to 2050, we're predicting to add about 3.5 billion people, or I'm sorry, 4 billion people, and almost all of them, 75% of them, are going to be in cities. So how do we put all these people efficiently into cities? Well, here's the skyline of Chicago, where I worked for several years. And so this tall building right here, as all of you budding engineers will know, is the Hancock Tower. But what we want to focus in on is actually this building right here, which is the Chestnut DeWitt building. And so if we could build at this density, and if we could figure out how to do that efficiently, we would be able to optimize our cities to be sustainable and also be livable. You'd enjoy living in them. And what's exciting for me specifically as a structural engineer, just to finish up here, is this idea of, as structural engineers, we get one shot. From day one of your building, so if you look at the life cycle of a building over 50 or 100 years, 80% of that is your heating, your electrical, your light bulbs, all that kind of stuff. But on day one of the building, right when you hand over the keys to the new owner, there's going to be 15% of 20%. So that's 75% of your embodied energy is associated with the structure. And so later down the road, you can always switch out your light bulbs to be efficient and all this kind of stuff, but you can't switch out your building structure. You get one shot at that to be efficient. And so that's what's really exciting for me, and really ultimately how I see an opportunity to make a significant impact going forward. So on day one, you've got 75% of that embodied energy is in the structure. So I have one shot to make a big difference. So with that, I just like to point out that here, one of the things that really excites me about Gonzaga is working both with colleagues like Dr. Mazinski here, as well as students. So we've had the opportunity to look at how you can utilize structural engineering and geotechnical engineering with a student to come up with affordable housing options, how you can use cross-laminated timber. Again, Seth is a former student of ours, to come up with unique housing solutions. So all that's very exciting. I get excited about engineering, but I also am really looking forward to the chance to work with you.